There are maybe 5 lifestyle changes that one can do, which is eat properly, don't overburden your mitochondria, let them sleep at night, exercise because you're benefiting your mitochondria throughout your body, not only your muscle, reduce stress in your life, and avoid things that are toxins in the environment, and try to minimize those as well.
You open the book with a devastating story about mitochondrial dysfunction misdiagnosed as poisoning. Why did you choose that story? And what does it tell us about mitochondrial awareness?
That story about Patricia Stalling and her 2 sons and her husband is really one that drew my attention, because it is a case where misdiagnosis could be so devastating. Let me tell you briefly the story. So what happened is Patricia had a child, and she noticed one day that he is leafless. He was tiny. He was still a baby. She rushed him to the hospital, and the hospital took care of him. And while taking care of him, discovered that he has abnormality in his blood sample analysis. What they found, they thought they found, is something that is found in antifreeze. Therefore, they thought that actually the mom is poisoning her own child. So they took the child to child services, and she could visit the child on supervised days, but she was never left alone with the child. And the child was doing better after they took care of this, the presence of this chemical in his blood. And then one of the visits, immediately after the visit, the child was sick again, got seizure, became lethargic. It was very dramatic, was rushed into the hospital. And the person who was supposed to supervise the visit, the nurse, said that she left the room for a few minutes. So they thought that, again, the mom was poisoning the child. And so she was put in jail, and eventually she was on a trial, and she was put in jail for a long time. While in jail, she discovered she's pregnant with a second child. And of course, once the child was born, they were given to the dad and to foster home. And after a few weeks, the child developed the same symptoms as the first child, became lethargic, had seizure. And that child was diagnosed with a certain disease that is a genetic disease that causes accumulation of this toxin in the blood because of a mitochondrial dysfunction. So now to the kicker. Now she has what supposedly evidence. She was not the poisoner because she was in the hospital. She was in the prison. Yet the decision of the judge was that it is she's still culpable about the first child, and she should stay in jail. Now, that was a story, and it was written in the newspapers, and people were talking about it. But eventually, 60 Minutes decided to do a story about it. In the meantime, the Department of Biochemistry at the University of Missouri chair was listening to this story. He was interested in genetics and genetic diseases, and he hired a new faculty member that was really bothered by this story. Kept thinking it doesn't make sense. If the second child has the same symptoms, then maybe the first child eventually die of poisoning. Rather, something is wrong with this child, the same as this new child. That story almost ended up as a no story until Sly, the chair of the department, ended up watching the 60 Minutes show and thought, okay, we have to do something about it. And what they did was very simple. They asked for the sample of the blood of that first child and the second child and analyzed it. And then they realized that the toxin that was found in the blood looks very much like the chemical that is accumulating in the blood of children that have this very rare genetic disease. Now the kicker, they got this evidence. They talked to the prosecutor, but it wasn't sufficient. So they decided to send the samples to many labs to show that it's very easy to confuse it to chemicals. And sure enough, some of the labs have made proper diagnosis of what the chemical is, and others confuse it with this toxin that is present in antifreeze. With that, the chair of the department wrote another letter to the prosecutor, and it was brought to the trial and to a second judgment. And the decision of the prosecutor was that she was not she should not be persecuted. And he apologized for what has happened to her. This is kind of a long story. And as I said, was particularly touching. We talked to Dr. Sly, who was then, I think, 95. He just passed away a few months ago. And when we talked to him, he was still equally emotional about it. And he said how misinformation almost kept an innocent person in jail, devastated by the fact that she has lost one child and another child she never had a chance to grow to raise. And it's all because of lack of information and awareness.
It is a devastating story, but you've got our attention as it relates to mitochondrial awareness.
Yeah, but I think the reason for us to write the book was not only to increase the awareness of us, the general public about it, but also the medical profession, and also to make us realize that there are so many things that we can do to take care of our mitochondria because they are so central to our lives, so central to our health. And until now, we're kind of ignored. I can say that I myself was actually guilty of that. I used to teach undergraduate students from atom to schizophrenia, kind of covering all the topics in science as an introduction. And when we reached the mitochondria, I kind of skipped it because there was just, I felt like, okay, it's really complicated. It generates ATP and that's it. And I hope that what people will learn is that the mitochondria is much more than the powerhouse of the cell. It does so many other things.
So in this heartbreaking extreme example, mitochondrial dysfunction showed up as essentially antifreeze, poison in someone's labs. How else is it showing up? I think of all the ailments, all the mystery illnesses, the lack of clarity on diagnoses, and I can't help but think, is it mitochondrial dysfunction at its core, and we're not really treating the root cause, we're just treating the symptoms. What's your view?
Yeah, very, very important question. So when you are looking at mitochondrial function in many chronic diseases, you find that they are not functioning properly. And so it's very easy to think, oh, the cause for the disease is mitochondrial dysfunction. But that's not necessarily correct. Those are just correlation. To show a cause, to show causality, that the dysfunction causes disease is different from just observing that the two are associated with each other. What I believe is by taking care of the mitochondria, we reduce the burden of diseases, not necessarily cure them. And that is by itself very important because the mitochondria are so central to our health. Does so many critical tasks that support our health. So it's not necessarily that mitochondria causes it or mitochondrial dysfunction is a cause for the disease, but by taking care of the mitochondria, both what we choose to do, so lifestyle changes, but also what the medical profession will do, will alleviate a lot of the maladies.
So if I back up a bit and zoom out, at its core, how would you describe mitochondria if you were riding in an elevator with someone and you had to describe what they do in 30 seconds or less?
So they are not only the powerhouse of the cells, they do transform energy from the food we eat into energy that is accessible to the cell, ATP, adenosine triphosphate. But they also control creating the building block for the cell, deciding when the cell should die or live, communicate with other cells, generate factors that affect how we behave, destroy or remove dysfunctional parts of the cell, make sure that toxins are detoxified. There isn't an aspect of our health that are not affected by this organelle.
So if there are wide-ranging implications, how does one assess how their mitochondria are functioning? In the same way, if I want to assess my heart, I can get a Clearly test. I can do my labs, my ApoB, my LPA, my blood pressure. Like, how do I know where I stand with regards to my mitochondrial health?
Yeah. Won't we wish to have a watch or a patch on our skin that will tell us your mitochondria is functioning well, or if I do this and this, the mitochondria is functioning better? Unfortunately, right now, we don't have such direct measures. We have indirect measures for how well the mitochondria, but unless we take a biopsy and actually look at the mitochondria, we can't really tell. I'm optimistic that actually we will have good tools to measure mitochondria in our daily life. But at the moment, I'm not aware of one that really works well.
So how does it, if there's no standard test, can you walk through how this will show up in someone's life with regards to energy, mood, cognitive function? Like, what are some of the symptoms that may be a sign that perhaps things are off?
Well, I think that we know when we feel well and when we don't feel well, right? That we know. And so the question is, what do we do with it? So number one is if we just kind of a little bit off, we can look at our lifestyle and change things that are all going to impact the functioning of your mitochondria. So we can go through that. But importantly, if you don't feel well for a while, consult professional people, go to your doctor, do blood tests, find out what's wrong. So for example, doing a blood test can give us a lot of information about whether the mitochondria is dysfunctioning. It will tell us also, do we miss something that needs to feed the mitochondria, like vitamins? So by going and getting professional evaluation, that's really going to be helpful. But there are small things that we can do, and we all notice it in our own activities. You don't sleep enough, the next day you're kind of off. You ate too much, or you binge during the night. You didn't go to sleep. Instead, you ate a huge meal. You know that. You didn't exercise at all. You are upset. You are very stressed. All these things are things that affect your mitochondria. And the good thing is that these things can be addressed. And when you know that by addressing them, you're helping your mitochondria, you know that you have power over how healthy you are.
So in terms of lifestyle, if you pull out your prescription pad and you're writing a prescription for mitochondrial health, what are the things that we should all be doing and doing more of? And then on the flip side, maybe avoiding or doing less of?
First of all, we have to feed the mitochondria. Feed the mitochondria is not only meaning giving them carbohydrate source and giving fat and giving protein, but also giving the right vitamins, minerals, and so on, all these micronutrients. Then we have to rest. We have to sleep. Mitochondria are doing so much work during the day, and during the night, they are busy recovering. I mean, do you know, we talked about ATP. Do you know that the mitochondria in our body, for each pound of body weight, they make about a pound of ATP, of this tiny molecule. This is so much work. And this is only one of the many things that it does. So if you don't let the mitochondria rest at night, you don't sleep, then they cannot do the recovery. Exercise is really amazing. I think that something really changed in the last 20, 30 years where people are so aware of the health benefit of exercise. What's important about exercise is not only that it uplifts your spirit, but actually the mitochondria in the muscle, when they improve, they send little treats, they send factors that help your brain, help your heart, help your kidney. So by exercising, you actually boost the health of the mitochondria everywhere in the body. Then you ask about what you should avoid. So emotional stress, it's difficult to say avoid emotional stress or stress in your life, but there are things that you could do. So we talk about that Emmanuel, my husband, and I, who is a co-author of the book, he's a writer, not a scientist, but we discovered quickly that watching 3 hours of news is extremely stressful. And so we switched that to consume news from other media. Or having a bad argument before going to sleep is not a good formula for good sleep, but also it's not a good formula for our mitochondria. And then there is avoiding of other things. So the mitochondria are the organelle that detoxify anything that we are generating in our body, but also everything that we consume from the outside. So pollutants, burned oil, barbecued food, pesticides, insecticides, all those are poisoning the mitochondria. So avoiding alcohol. So avoiding or reducing the exposure to these things will help your mitochondria. So there are maybe 5 lifestyle changes that one can do, which is eat properly, don't overburden your mitochondria, let them sleep at night, exercise because you're benefiting your mitochondria throughout your body, not only your muscle, reduce stress in your life, and avoid things that are toxins in the environment and try to minimize those as well.
Very straightforward. And I want to drill down on diet and exercise specifically. I think what we should avoid, everyone understands stress, totally get it. But in terms of diet, can you drill down a bit? What should we really be enjoying there? Or are there certain foods that you find extraordinarily beneficial that we should be trying to incorporate into our everyday lives?
I appreciate that you ask certain foods rather than a food, because I think we all kind of want to have this magic formula.
If you got it, I'll take it.
Exactly. If you got it, I'll take it too. Water is good. Um, yeah, we wish that, and that's actually could be very bad. You have those biohackers that say, "Oh, just eat grapefruit or just drink cabbage soup or whatever." What will be good to eat is something that is balanced. So it's first of all a meal that has protein source in it, that doesn't have refined sugar in it, or that has vitamins in it. So it's fresh vegetables and food and fruit. The usual things, fats, the right fats. So the right ratio of omega-3 to omega-6. So more fat from vegetables and not from animals. All these things that I don't have news there. But what I want to say is about eating that is really important is to realize that we shouldn't force everybody to use one formula. If you eat that, you guarantee to live forever. We eat the Mediterranean diet because we are Mediterraneans. So it's natural for us. We love fish. We eat a lot of salads and vegetables and fruit. Perhaps somebody in Finland would not do well on Mediterranean salad because over evolution, they were exposed to different kind of food source. So there isn't one formula for all, but following common sense, not overburdening your body with, huge cakes and large alcoholic drinks and all that. All those are things that are good for you.
So it sounds like a whole foods diet for the most part.
Yes. Let me tell you something that I didn't know when we worked on the book. I discovered that. So, of course, we all know about how important it is to eat a lot of fiber. And in fact, we thought we are very good. And then we discovered that we don't consume the 25, 30 grams of fiber a day, even though we eat a lot. So we now add half an avocado to our salad or things like that. I thought that fiber is important to be regular. And what I discovered in my studying this topic was actually what we do is we feed the microbiome with fiber so that they convert it to a compound called butyrate. And this butyrate is feeding the mitochondria in the lining of the gut. The mitochondria in the lining of the gut are critical in keeping the bad stuff out of the body, bad bacteria and so on. But those bacteria in the gut, the good one, are producing something that is critical for the health of the gut, which is this butyrate. Two things happen. If you don't eat enough fiber, you don't make enough butyrate, you don't feed those mitochondria, so the lining becomes thinner. But there is another problem. Lining becomes thinner also because there is another layer, which is this mucus that these cells are making. And in the absence of fiber, the bacteria in the gut starts to chew this mucus. And now that becomes thinner. And now things that we ingest that contain bacteria in them or parasites in them can penetrate the bloodstream and cause disease. So fiber is not only for keeping us regular. We feed the bacteria that are living in our gut.
I'm glad you call out butyrate. So that's an important one we don't talk enough about.
Yeah. Let me tell you another surprising things about feeding bacteria. Did you know, and I did not know that, did you know that in mother's milk, there is a fiber kind of compound that the baby cannot digest, but it is for the bacteria that start to populate the baby's gut. So we, mothers that nurse their children, make this product to feed the bacteria, not to feed the baby. Of course, they produce also things that feed the baby. I mean, it's amazing to think that communication between the two tribes, as we call them.
It is. I find the microbiome fascinating, and we've come so far, yet it still feels like we're in the primitive stages here, that we're just beginning to understand its impact and what to do.
I'm excited what's going to happen now in medicine. Starting to appreciate the microbiome is one field. Starting to appreciate the mitochondria is another. I believe that this new knowledge or this deeper knowledge matters not only because it's exciting as a scientist to follow that, but because it can impact our health.
I agree. And they're connected. It's this bigger idea. You talked about stress. There's, the brain body connection, the brain gut connection, and this idea that we're not siloed and how all these things are connected.
Can I tell you something about myself? So when I started to think about what I want to work on after my PhD, I thought I really want to work on mind-body connection. How is the body affecting our mind, our feeling, and how can that can feedback to our health? And I was looking for a lab that is and a lab that has expertise in that. And the only labs that I found were either in the Eastern Bloc or in Southern America. I didn't find anything in the US. I didn't find anything in Europe at that time. So I gave up on it. We're talking ancient history here. So I gave up on it. And I'm so happy that now, in a way, I'm working on that. We now know that if you exercise, factors in your muscles are helping your brain. And when you are resting, factor in your brain affecting your body. But the wonderful aspect of that is that, and we can affect it. Simple lifestyle approaches can affect it. I mean, how wonderful is that?
It is. And you mentioned, so exercise, something you mentioned before and brought up again. What do we know about dosage and type as it relates to mitochondrial health?
First, let's start with a disclaimer. I'm not an exercise guru. I'm not a health guru, okay? I'm a protein chemist by training. I love the mitochondria, and finding all the things about mitochondria and lifestyle made me think about that much more. Okay. So there are lots of, again, formulaic advice. Oh, just do HIIT. Or just do, just do endurance. Again, the way I assessed it is by actually reviewing the literature. Studies in human, not only studies in animals, taught me that there is a very strong evidence that doing both kind of endurance and weight exercise, resistance exercise are the best one for your mitochondria. But there is also another element, which you mentioned earlier, and that is what it does to our spirit, right? What it does to our well-being, the emotional being. So if for you, HIIT is making it, then by all means. Or if for you, walking, the way I do it, is doing it, then do that. It's very important to incorporate into your life.
Well, do you think there's a negative impact? Or maybe not negative, that's a strong word, but maybe not necessarily the greatest benefit if you take on an exercise which you absolutely loathe versus one you love?
I loathe exercise.
You loathe exercise. Okay. But you like walking. So you get more benefit out of walking.
I walk to work every day. We have one car. I walk every day. That's my favorite time of the day, to walk to work and back. I'm so lucky because when I walk, I look at greenery, and I live in a beautiful area. So it's very calming. It also allows me to kind of, especially when I walk back from work, to kind of, lower the energy to the home energy. I love that. I, for years, didn't like exercising, but then I realized that how important it is. And actually about now 25 years ago, my husband and I said, okay, we have to do something about it. And so we took a trainer, and we started to go to regularly to exercise because we recognize the benefit of it. Going there, I always kind of complain. Coming back, I was always very happy about doing it. So making it social, having company to do that, find your own tricks to do it. It's one of those things that are really good for you. So I do it.
Jason Walkup here, founder and co-CEO of mindbodygreen and the host of the mindbodygreen podcast. Please subscribe. You'll never miss a show, and you won't regret it. As do I, and most of our listeners do too, I'm assuming. So I want to come back to how mitochondria can help determine essentially which cells live or die. And I think about the implications with diseases like cancer, Alzheimer's, even long COVID. How do you think about therapeutic interventions for someone who's concerned about any of those afflictions I just mentioned and intervening, is there a pharmaceutical? Is there a supplement? Like, how should one think about mitochondrial function if they're concerned?
Okay, first let's start with something I believe very strongly about. The worst things that happen to somebody who is ill, who is sick, is for them to feel like it's their fault. That if they did better imagining, and if they wouldn't get cancer, or they fight the cancer by themselves, or if they. So I think getting guilt out of being sick is very important, but not feeling helpless when you're sick are the things that you can still do. So let's just get out of the macro and go to the nano or micro. Mitochondria, the organelles that generate energy, can decide this is time for that cell in which I'm in to die. And they do it actively. The same component that is important to transfer the electrons in order to make ATP, this accessible energy source in the cell, is coming out of the mitochondria at the right time and triggers the process of cell killing. This process is essential. Why do we have a cell-killing machinery? When an embryo is made, their hands is like a mitten. In order to get digit, you have to kill cell in between the digits. And the organelle that does it is the mitochondria. Same thing in the brain. You are born with way more neurons in your brain, or not born, but even during embryogenesis. And then you need to remodel, chisel, get the right things out, and flourish, and things that are bad, remove them. So this is something that the mitochondria do. But they do something else, which is related to the disease. They are ancient bacteria. The thought is that about 1.5 billion years ago, they emerged with these archaic cells. They delegate a lot of things to the nucleus, to where we have most of our DNA, but they kept some things on their own control. And like other bacteria, they are territorial. They don't want new things coming into the cell. So when a virus comes into the cell or a parasite comes to the cell, they trigger a fight. First of all, they try to kill it. And we'll talk about that if you have time. But more importantly, they alert the immune system, hey, there is an invader here. You have to do something about it. What they trigger is an immediate immune response that is different from the immune response that we are usually talked about when antibodies are made or when cells come and eat the cancer cells. The first response, this innate immune response, takes seconds to be activated. So they are always ready to shoot, so to speak. The acquired immune response requires weeks to generate antibodies and cell immunity. So those cells are our first front to protect us from invaders. They sense it and they act on it. So we gave 2 examples of how they are positive in chiseling the final shape of the body, but we talked also about how they fight viruses. Now, what about cancer? Shall I go on?
Sure, cancer or long COVID. I think that's super interesting right now. I think more people have it than they're aware.
Let me start with cancer because that was another jaw-dropping learning for me about cancer. Cancer cells are true bandits. They are just terrible, egotistic cells. They don't care about the cells around them. So they divide like crazy, don't respond to the fact that other cells are pushing on them. They just grow. Because they grow so fast, they have to use a lot of energy. But they don't care about the rest of the body, and I'm using terms loosely. So they use glucose, but they do not metabolize it in the mitochondria. They metabolize it kind of quickly in the cytosol, in the liquids that surround the mitochondria and other organelles in the cell. Why does it matter? Because they generate only 4 molecules of ATP for each glucose, whereas if they did it together with the mitochondria, they would have made 32 to 36 molecules of ATP. Huge waste. Why do they do it? Because it's faster to get the energy and because, so to speak, they don't care. They're also becoming independent of oxygen because to make 32 molecules of ATP in the mitochondria, you need oxygen. And blood vessels don't grow fast enough to feed the tumor, the cancer. And so they said, okay, forget about it. I'm going to not use oxygen for that. Not all of the things that the cancer do. They do more. After a while, they say, okay, but my mitochondria, I need them for many other things. I need them to create building blocks so I can make more proteins, more DNA, and so on. I need them to store calcium. And so what do? They send long tubes into neighboring cells, especially the T cells, the immune cells that come to kill them, and they siphon out, they steal the mitochondria from the immune cells into themselves. Not the end. They have bad mitochondria in them. What do they do with that? They inject them into the cells around them. And finally, the bad mitochondria that they injected to the neighboring cells are covered with kind of invisibility coat. And all the things that I'm telling you is the last 3-4 years. What does it mean? It means that now we understand better how to kill these cells because they do so many things that are different from normal cells. It's like, when you are trying to find robbers that just robbed a bank and they are in their car trying to escape the police. A very easy way to find them is if you fly in a helicopter on top and you see a car that is zigzagging. They also zigzag. They do things out of the ordinary. So knowing all this information can be capitalized to kill them because they have features that are unique to them, different from the cells around them. So I'm very optimistic. This is an example.
It's fascinating. And it feels like hearing you speak and what I've read and heard anecdotally, we're on the cusp of some very serious breakthroughs with regards to treatment and potentially eradication of cancer in the next 5 to 10 years.
I'm very hopeful, but I'm not giving timeline. I think that the more we discover, the more optimistic I am that we will sort it out. I work in science, truly believing that it's a finite problem. Eventually, we will understand all of it. We dig and dig and dig and we find more elements, but eventually we will sort it out. I think that it's pretty amazing to watch what happened in science, even in the last 50 years, definitely in the last 10 years.
I just think about the conversation we're having today about mitochondrial function and the broad-ranging implications. And that wasn't something we were speaking about just a couple years ago. Are there, you mentioned biohackers earlier. They've got shortcuts for everything. Everyone loves a good shortcut, including me, or a magic pill. Are there any, what do you see biohackers talking about as it relates to mitochondrial function and a pill or a hack or whatever it might be to, keep the good cells, kill the bad cells, live forever? Well, what do you see that you're like, oh no, we've got this completely wrong?
Unfortunately, I see quite a lot of wrong. People are recommending things that are really dangerous for you. People are connecting observations that show correlations to causality. But more importantly, that people that are listening to it don't choose the right tool to decide whether it applies to them. So one thing that we've done, so it's frustrating. So who do you listen to? I think you should listen to your physician, but you should also listen to your own body. But let's see, you hear somebody who recommends something and you are very interested in following it up. Then we give kind of a short guidance to think like a scientist. First of all, who is the person that is saying? What's their credential? All easy to figure out. Then is the recommendation based on animal studies or just cell in culture studies? Or is it really done in human? If it's done in human, is it a correlation? In other words, all people that eat bananas have longer fingernails. Or is it because if double-blinded study in which bananas grew longer fingernails in those that consumed them, but the other ones didn't grow longer, and so on. Okay, correlation versus causality. And finally, is it related to you? Is a study that was done? Is it people like yourself? So for example, if you're pregnant and you hear that you should take compound X because it prolongs the life of old men or improves their brain function, should you take this on yourself? So it's not, it sounds like I'm saying, think like a scientist. Oh, I'm not a scientist. I can't think like that.
Agree with everything you said. I think we're getting to the point with AI where you almost can think like a scientist. And I'll tell you what I do personally. So I have my great doctor who I see, Frank Lipman. I have a genetics test. So I've done that. I do my comprehensive lab work. And so I will plug that in to AI. And I know the prompts, and sometimes AI gets things wrong, but I will plug in all the supplements of ours I'm taking. I'll plug in my stats from Aura. I'll plug in, this is what I'm looking to achieve. And I get back almost a personally prescribed protocol in terms of what I should eat. Sometimes I will go as far, and I don't do this all the time, but sometimes I'll do it. If we go out to eat at a restaurant with my family, I'll take a photo of the menu. I will upload it to AI and say, given my genetics, lab work, and goals, tell me what I should eat. And that's the place I think, I'm not suggesting we all, go to AI every time we want to eat a bite of food, but to your point, we're all individuals. I think we're on the cusp of that, where, bananas, I'll use this example as banana, rather benign, but bananas may be fantastic for me, but for someone around the corner, they may be terrible.
Okay, you are making excellent points. And by bringing genetics as a first point is really, you're making a point that we didn't discuss before. I want to discuss it for a second.
And labs too, because genes aren't your destiny.
So true. Okay, so let's start just for genetics. I mentioned in passing that we eat Mediterranean diet, and it's natural word Mediterranean, so that's what natural for us. But also I mentioned that maybe it's not good for people who grew up, let's say, in Northern Europe or in East Asia. Why is that? Because there are certain traits that we acquire in evolution over time that are giving us certain advantage. For example, there is a gene that makes us better at fighting malaria, but it actually makes us incapable of metabolizing certain food like fava beans. So these people exposed to fava beans will have hemolytic anemia. Their red blood cells will break. This food is not good for them because they have this trait that doesn't allow them to eat fava beans. But they were never exposed to fava beans for millennia. They were exposed to malaria, and they managed to survive it because they had these mutations that helped them with that. So genetics matter. But, I'm a scientist and I don't do what you do. I'm a very rational person and I don't do what you do. And the reason for that is also what makes you happy. I think it makes you happy. I think that, and for me, these things don't make me happy. To be totally obsessed with, not obsessed, sorry, it's giving a grade to what you do, but kind of preoccupied with that. I think, laughter and happiness and doing things that are satisfying and exciting, being social, thinking, reading, listening to music, hugging your kids, all these things are very important and take time. And if I did the things that my science will guide me to do, such as examining what it is that I eat every day and what's going on, I will not be able to do the other things that give me joy. So we have to kind of balance it. But I think you're saying very important things, and that is how the combination of your blood tests, your genetic makeup, what you're exposed to, can really impact your health. And what do you do with this information? AI is one. When it becomes really, really reliable, that would be better, because I worry sometimes it makes silly recommendations. or hallucinate solutions that don't exist.
Oh, it makes mistakes for sure.
Yeah. But it's what you're saying is what I said earlier. It's a finite information. And it's very possible that we will have the perfect guidance. And so we'll be born with an instruction and we will follow this instruction and voila, we will be healthy forever.
Yes, and 100% agreed. You need to bring joy into this. And the reason, my disclaimer here, I am being so rigid right now with regards to my diet is doing blood work. It came up. I have long COVID and it's impacted some of my, I'd say, neuroinflammation, which I'll save for another episode. And so I am on a rather rigid protocol to clear out the COVID and to clear out some of the neuroinflammation. And so I'm a very strict 90-day, I would say 80% strict protocol for 90 days to see if this works, which I will save for another episode. But I think that's amazing that I have this information.
I agree. I want to say that what I was talking about is people with more or less normal health. I would say I'm very lucky. I agree. And we have a friend that was diagnosed with Parkinson's disease. And he just took it on himself to fight it. And he takes his medication, but he goes to the doctor, but he has a trainer that exercises with him. He's considering what kind of food he's eating. Yes, those are the things about taking control and doing.
It's empowering.
Exactly. Not feeling helpless.
You don't say, I'm a victim of this ailment, and you there's so much we can do.
And it's important to feel that you have a role in it. So they do a lot. The mitochondria do a lot for us. Sometimes they falter. We can do things to pick them up. And maybe I want to say one more thing that is very important, and that's more optimistic. One of the amazing things about our body that we have a huge reserve, that it takes 80% of the neurons in our brain that control movement to die before we actually show symptoms of Parkinson's disease. It takes 80% or almost 80% of the pancreatic cells that make insulin to die before you are diabetic type 1. Huge number of mitochondria in each cell, hundreds to thousands mitochondria in each cell. So we have a huge reserve. And then there is a threshold from which things are going bad. It is also shown in other studies where there is mitochondrial disease, where not all the mitochondria are defective, mitochondrial primary disease. And there is a threshold for that. What does it mean that there is a threshold? That you can pedal against that current, move away from the brink, and be better. And I think that's what you're doing.
It's fascinating. Thank you. So in closing, other than pick up your book, which is called The Life Machines, fascinating read, very much enjoyed it. What's one thing, if you could just recommend one thing that everyone should do today, what would it be?
It's difficult to say one thing because it's frustrating me to say one thing. But let me say one thing is that I'm always saying to myself, to my kids, to my students, find what brings you joy, because joy is what brings your health of the mitochondria. But it's not enough what I'm saying.
No, I'll take it. Let's take the joy and run with it. Let's close there. I love it.
So bring joy. Yeah. I hope I didn't left something important on the table.
I don't think we talk about the importance of joy. I'm a big believer in that. My wife and I literally wrote a book that came out a couple of years ago called The Joy of Well-Being. So I am with you 100%. Daria, thank you so much.
Oh, thank you. I really appreciate the opportunity to talk about it, Jason. I really appreciate that.